All right, every site engineer knows this moment, right? You get handed this super complex HVAC drawing, just a sea of lines and numbers. And the big challenge is always, how do you turn this piece of paper into a living, breathing system? Well, in this explainer, we're going to break it down and build the complete step-by-step execution plan to make that happen from start to finish. So here's our game plan. We're going to tackle this in 4 key stages. First up, we'll decode the blueprint's language. Then we'll turn that plan into a real-world installation sequence. After that, it's all about quality and precision with smart scheduling. And to wrap it all up, we'll bring the entire system to life through final testing and commissioning. Okay, let's dive right in. Look, everything starts with the drawing. Before a single piece of duct is even lifted, we have to get really good at reading and understanding every single critical piece of information that's on that plan. I want you to think of the HVAC drawing as the single source of truth for the entire project. I mean it. Every decision you make, every material you order, every single installation action, it's all guided by what's on this page. This is basically the constitution for our entire scope of work. So how do you even approach this thing without getting totally overwhelmed? It's simple. We break it down. First, find your main equipment, your air handling units, your fans. From there, you physically trace the main supply duct. That's the system's highway. Then you follow all the smaller branches out to the rooms they serve, and finally, you decode all the symbols and the data that give you those critical specs. And let's be clear, these specs are absolutely non-negotiable. If you get the duct sizes, the lengths, or the cages wrong, well, you've just created a massive procurement headache, and worse, a potential performance failure down the line. This data isn't just a suggestion, it's the direct input for your bill of quantities, your BOQ, and it drives your entire fabrication and purchasing plan. Okay, so now that we can read the plan, it's time to actually build. With a really solid understanding of the blueprint, we can finally translate that knowledge into a physical installation sequence. This is where the plan really meets the real world. Now, this sequence is absolutely critical, and it's designed specifically to prevent rework. You always start with the heart of the system, the AHU. Then you build out the skeleton, the hangers and supports. Why? Because you have to establish the exact elevation and slope before you lift a single heavy duct section. Once the supports are in, you build the highway, the main duct, then connect the local roads or branch ducts, followed by all the control fittings and terminals. But you gotta remember, no step happens in a vacuum. Let's just take one single activity, installing the main duct, to see how procurement, safety, and quality control have to align perfectly for it to work. So for this one step, think about it. Procurement needs to make sure the right materials are actually on site. The safety team has to approve a job safety analysis, or JSA, for working at height. Quality control needs a material inspection request, an MIR, signed off by the consultant before that material is installed. And of course, the coordination team has to verify all the ceiling clearances so we don't clash with plumbing or firefighting. All of that just to hang one section of duct. With the physical system starting to take shape, our focus now shifts over to verification and management. We have to ensure that what we've built is not only correct according to the drawing, but that we're also staying on schedule. And this whole thing is managed through a pretty formal process. For each major activity, the contractor submits an inspection request, an IR. The consultant then comes out, inspects the work on site, and either approves it or rejects it with comments. This creates a documented paper trail of quality assurance for the entire project, which is so important. And the standards for approval? They are tough and non-negotiable. Installation has to comply with industry standards, like from SMACNA. Duct gauges must match the approved drawings exactly. And this is a big one. Leakage and pressure tests have to be done before anything gets concealed by a false ceiling. Trust me, this guarantees system performance and avoids incredibly costly demolition later on. So this is where we add that fourth dimension, time, to our 3D plan. By breaking down the installation sequence into a schedule, we can create weekly and monthly look-ahead plans. And this is what allows the site team to manage resources, manpower, and procurement so much more effectively. So we've built it, and we've verified it. Now comes the most critical phase, bringing the system to life. This is where we flip the switch and meticulously test everything to make sure it performs exactly as the design intended. A huge part of this is something called air balancing. See, the drawing specifies a very precise amount of airflow measured in cubic feet per minute, or CFM, for every single diffuser. Our job is to go out and measure the actual airflow at each one, and then fine-tune the dampers until the real-world value matches the design value. This is how we guarantee every single room gets the right amount of air. It's a game of precision. And this process follows a very strict checklist. We do our final pressure tests to make sure there are 0 leaks. We perform the airflow balancing we just talked about. We follow the official startup protocol for the AHU to the letter. And finally, we prepare the as-built drawings that show the final installed condition and hand over all the documents, which officially closes out the project. So, the crucial point here is that an HVAC drawing isn't just a picture. It's a detailed set of instructions. And by following a systematic approach, from reading the plan and sequencing the work to ensuring quality and commissioning the system, we can successfully transform that complex blueprint into a project reality. So the real question is, are you ready to make it breathe?